Look at the intermediate value problem. The intermediate value problem says that if there is a function f which is basically continuous over interval a and b, there exists a value k that is between f of a, so we can say it's between f of a and f of b. Then there exists a value c, so that f of c equals k. So to make it very easy graphically to explain, it says that if we've got a function, let's draw a function, and we've got two values, we've got an a and we've got a b. Say we want to see if there's a value of x that's equal or to 0, so in this case we want to find the value of c where the value is 0. And we've got f of a, which would be the y value at that point, and f of b, which would be the y value at b. And if f of a is greater than 0, so it's above the x-axis, and we've got f of b which is smaller than the x-axis, then there must be a value c in between the two that the value f of c would be equal to 0. Okay, so this means that if we have a problem that says, okay, we've got a problem that says that, let's look at this equation. We've got x minus 2 squared minus ln x is equal to 0. So we want to find out is there a value of c where the function is equal to 0, because they ask where the function is 0. And we're looking at the interval between 1 and 2. So we must prove that there's a value that exists, c, so that f of c is equal to 0 between 1 and 2. To solve this problem, we substitute 1 into our equation. So we get 1 minus 2 squared minus ln of 1. And this would be then minus 1 squared minus ln of 1. We know ln 1 is 0. So this answer will be 1. So this will be greater than 0. Now we do the same for the other end of the interval. This will be 2 minus 2 squared minus ln of 2. And we know that 2 minus 2 squared is 0. We know that ln 2, if we look at the ln graph, remember it looks something like this. This is ln x. This is at 1. So if you're greater than 1, ln x would be positive. So ln of 2 would be positive. So minus ln of 2 would be negative. So we know that this value will be, we can go back here and say this would be minus ln of 2, and this is less than 0. So what we know here is that we know that f1 would be between f of 2 is smaller than 0 and f of 1 is greater than 0. So we know that c would be between the two intervals 2 and 1. And this is the intermediate value problem. So we've proven, because the one value is bigger than 0 and the other value is smaller than 0, we've proven that there will be a value c that's between these two intervals. And that's the intermediate value problem.